Hello class, in this video I'm going to show you a few examples on how to use linear inequalities and how to graph them. First of all, remember that the inequalities are less than, greater than, less than or equal to, greater than or equal to. So the most important part is to understand which symbol is used for less than and which symbol is used for greater than. In this case, one of the things that you could use to remember is that the word less than, the letter L almost looks like the less than sign, capital letter, and then greater than will be the other one. And so that's one way you could memorize that, less than and greater than. And of course, we have other symbols, other signs that we use. That'll be the greater than or equal to and the less than or equal to. Okay, so keep that in mind. So one of the things that we're gonna do, one of the examples that we're gonna do on this section is, they're gonna give us an inequality and we're gonna check if the point that they give us is a solution. So remember, this is x, this is y. So we just substitute it. X is 3, y is 2. And we're gonna check if this is actually greater than 5. It turns out 5 is equal to 5. So since we don't have the equal under the greater than sign, this is a false statement. And because it is a false statement, that tells us that 3, 2 is not a solution. Okay, hope that was easy. On the next example, it's the same thing. X is -1, y is 2. When we substitute it in, -1 plus 2 times 2. Question, is that less than 4? Well, we know that -1 plus 4 is 3. And 3 is certainly less than or equal to. Less than 4, and it's not equal to, but as long as it's either less than or equal, it's correct. So this is a true statement. And therefore, -1, 3 is a solution. Okay. Take a look at the next example. Same idea. This is x, this is y. 5 times 2 plus -2 is less than, strictly less than. 10 minus 2 less than 8. 7. Obviously, 10 minus 2 is 8, and 8 is not less than 7. This is false. And because it is false, that means that no, 2 is not a solution. Okay, I forgot to give you a point on the next one, so let's write down here. Let's do -2, -3. Well, -2 for x will mean negative because there's a negative here, and a -2 because x is -2. And we're going to see if this is greater than or equal to -2 times -3. This is 2 minus 5. Is that greater than -6? Positive 6. And so this is -3, and -3 is greater than 6. What we do is we look at the number line, and on the number line, we notice that -3 is here and 6 is here. 6 is on the right side of -3. That means 6 is greater than -3, or we could say -3 is less than 6. That means this is false. So this is not a solution. Okay. On the next example, it's very similar, except this time they give us a graph instead of the equation. Well, they give us the inequality too, but it's easier if we just look at the graph of this inequality. We're going to see later on how we graph that. But right now, let's just use the graph that they give us. And so we're going to see that the shaded region represents the area where all the solutions are. And so if 2, 1, which is here, 2 to the right, 1, because it lands in this shaded region, that means this is a solution. So yes, 2, 1 is a solution. -1, 3, the point -1, 3 is here, and it's not in the shaded region, so it's not a solution. so no. What about the point 1, 3? 1, 3 would be here, 1 to the right and 3 up. It's actually right on the line. When we graph a dotted line, that means the points on the line are not solutions, so no. If it was a solid line, then it would be yes, definitely a solution, but it's on a dotted line, so all the points on the line are not solutions. And then finally, 0, -1. 0, -1 is here. It still lands on the shaded region, so yes, it is. Okay, please feel free to rewind this video if you don't understand, but hopefully you do. And then the last part of this video concludes with how do we graph an inequality with only one variable, but on the x and y plane. And so if you remember, y equals, so pretend we're graphing the line y equals is a horizontal line that passes through -2. And one thing you want to remember is what I have here on the note. Whenever we have less than or greater than, less than or greater than, I don't like the way this came out, so let me erase it and I'll rewrite it. So for greater than or less than, we're going to use dotted lines, and for greater than or equal or less than or equal, we're going to use solid lines. Again, solid line meaning that the actual numbers on the line are part of the solution. And here, since on the first, on example 3a, since we're talking about y is greater than -2, greater than means on top of it, so up here. So we're going to be shading all of this region, and all of these are, that's where all the solutions are. Okay, if you look at example 3b, x is less than 1. X is equal to 1 is a vertical line, and because we do have the equal sign, we're going to make it a solid line like so. And then we're going to shade to the left because the numbers less than 1 are on the left side. So we're going to shade here and here. Okay, and remember the shaded region is where all the solutions are. Please feel free to watch this and other videos and rewind them and use as many times, watch them as many times as needed. Again, a y equals is a horizontal line, x equals is a vertical line. And then remember to use dotted lines for when we don't have the equal sign, and solid lines when we do have the equal underneath, okay? Thank you. I'll see you next time.